Today's lesson is solving polynomials. So the fundamental theorem of algebra says that any polynomial of degree n has n roots. And we've talked about this a little bit in the past, I believe. So that means if it has the power of 2, there are 2 roots. If it's power of 3, there are 3 roots, and so on. Some important notes that repeated roots count multiple times. So if it was like x equaled, if it was like x minus 2 and x minus 2 were both factors, x would equal 2 twice. So that would be 2 different roots. And the roots can be real or imaginary. So essentially, degree is the number of solutions, real or imaginary. So to solve, we're going to make sure it's equal to 0 first. Or if it's given to us as f of x equals, we make that equal to 0. We follow whatever steps we need to factor it, right? We might have to graph using technology to find an integer root first. We might have to use synthetic division. We might have to use quadratic formula. If we're able to factor, we're just going to set each factor equal to 0 and solve each one, right? And other ways they might ask you to solve might be find the zeros, find the solutions, find the x-intercepts, or even find the roots. If it's not factorable, like I said before, you could use other methods like quadratic formula to finish. But what we're going to make sure we do is when we divide both sides of an equation by something, we don't ever get rid of variables. So if we were going to divide both sides by x, it doesn't go away. It just goes on the outside of them, right? It becomes a factor on the outside. Example 1, let's solve by factoring. There's definitely a GCF here because all of these are divisible by 5 and they all have x's. So we're going to divide everything by 5x first. So the 5x will go on the outside. That'll leave us x squared. 40 over 5 is 8. Now just x, and 80 over 5 is 16. So this is a quadratic that is factorable. We're going to look for the two numbers that multiply to 16 that add to negative 8. Oops. Negative 4, negative 4. So negative 1 and negative 16 doesn't work. Negative 2, negative 8 doesn't work, but negative 4 does. So it's going to be 5x, x minus 4, and x minus 4. So any place we see an x is a factor. So this is a factor. So that would be set equal to 0 and solved, even though all we're doing is dividing both sides by 5 so that x is equal to 0. This is a factor, right? So x minus 4 is equal to 0. If I add 4, I get x is positive 4. And as long as there's no number in front of the x, it'll always just be the opposite sign of that number inside. And this is another x minus 4, which means it's twice, but I don't have to list it twice. I'm just going to write it like this. X equals 0 and x equals 4 are my solutions, even though 4 appeared twice, and that's a total of then 3 solutions for my power of 3 problem. All right, we have another GCF here. So if I take out the x, I'm left with x squared, 1x, and minus 6. So looking at what multiplies to negative 6 and adds to positive 1. I would say negative 2 and 3 does it. So x minus 2, x plus 3. Right? If I set the first term equal to 0, x is just 0. If I set x minus 2 equal to 0, x would equal positive 2. And if I set x plus 3 equal to 0, x would equal negative 3. There's 2 here for you to try. You can pause. Answers are posted in Google Classroom in the blank notes. So example 2, find the zeros. We have 3 terms. It looks like a quadratic, but it's to the 4th power. The second term is half of it, so that works. So we're going to look for what multiplies to positive 45 and adds to negative 14. Negative 5, negative 9 does it. So that means instead of x, it's going to be x squared minus 5, x squared minus 9. Now here's something that I'm going to do a little differently. If this just said factor completely, I would go further on this one, the x squared minus 9. But because it does not say factor completely, it's just find the zeros, I'm going to treat these as just solving by square roots. Because if I take the factor of x squared minus 5 and set it equal to 0, I would add the 5, and then I would take the square root of both sides, getting the positive and negative answer there. And I could do the same thing here, right? If x squared minus 9 is equal to 0, add the 9. When I take the square root of both sides, I get the positive and negative answer. Now, if I had factored this further, I would have had x plus 3, x minus 3. And if I set x plus 3 equals 0, I get negative 3. And if I set x minus 3 equals 0, I get positive 3. So I still get the same two answers there. So both ways will work. But as long as I have just something squared in a number, I can solve it by using my square roots. All right, for example 2b, I don't have a GCF because there's nothing that goes into 4 and 5. I just have 4 terms, so I'll start by grouping. No number comes out of these, but they both have an x squared. So that leaves me with 4x and minus 5. These are pretty big numbers. I see a 25 there. 25 also goes into 100. So I'm going to say 25 is going to come out, but it's negative here. So I'm going to take negative 25 out. So that gives me a positive 4x and a minus 5. Goody goody, then match. So now my factor of 4x minus 5 would be set equal to 0. Add the 5. Divide by the 4. My x squared minus 25 would get set equal to 0. Add the 25. And take the square root. Don't forget to get both the positive and negative answer. All right, example 2c. I do have a GCF here. I could take a 5 out, and I'm going to go negative 5. And I could take an x cubed out. So when I do that, I get positive 4x plus 3. So now I can set each of these factors equal to 0. So negative 5x cubed equals 0. It's just going to be 0. And 4x plus 3 equals 0. I would subtract 3 and then divide by 4. All right, last example here. This is not equal to 0 yet. So I'm going to start by subtracting the 14x to the third and putting it in standard form. Now I'm going to worry about a GCF. They're all even numbers, so I could take out a 2 from everything. And I could take out an x from everything. So now I'm left with x to the fourth minus 7x squared plus 12. We don't have a number in front of this. This 2 is half of 4, so this will work. So we're going to take the two numbers that multiply to 12, that add to negative 7. Negative 3 and negative 4 does it. So it would be x squared minus 3 and x squared minus 4. So setting 2x equal to 0, we get x is 0. Setting x squared minus 3 equal to 0, we get x is plus or minus square root of 3. And by setting x squared minus 4 equal to 0, we get x equals plus or minus 2. So that was 5 solutions, and it was a power of 5. So here's 2 for you to try. You can pause. The answers are posted in Google Classroom. So for example 3, it says find all solutions of this. Graph first to find an integer solution to divide in. So I've already gone to Desmos and I've graphed this. And I see that I have an integer solution at negative 2, 0, right? That happened between the 2 and the 3. This happened between the negative 3 and the 4. But negative 2 works. So we're going to take the negative 2 out first. All right, put our coefficients. We're going to do some synthetic. Bring it down. We're going to multiply and then add. We're going to multiply and then add. We're going to multiply and then add. So what I'm left with is x squared plus x minus 7 equals 0. Now the only things that multiply to give me 7 are 1 and 7, and no combination of them will equal positive 1. So this is actually a problem that we're going to have to finish off by using quadratic formula. So remember, quadratic formula has a, b, and c. It's going to be negative. Well, let's go a different color now. Negative b, so b was 1, plus or minus the square root of b squared, so 1 squared minus 4 times a times c is negative 7, all over 2 times a. So I'm going to continue my work down here. So that's going to be 1. Negative 4 times 1 times negative 7 is plus 28 over 2. So that becomes 29. So I have negative 1 plus or minus the square root of 29 over 2, which cannot be simplified any further. And from what we originally graphed, x equals negative 2. So there's a final one here for you to try. You can pause, or you can end it here. The answer is posted in the blank notes on Google Classroom, and that is solving polynomials.